So now we're going to kind of put all of that proof reasons into play here. So a proof is a logical argument that shows a statement is true. So a two-column proof, we already kind of talked about that we have numbered statements and corresponding reasons. Just like in our algebraic, it kind of works for our segment and angle proofs as well. So valid reasons, we can see that proof sheet for all of our valid reasons. And then when we write proofs, we always write the given information first. The last statement in the proof should always be what you're trying to prove. But the reason is never prove. That's not an actual legitimate thing that means anything. So prove or proof is never reason, but given is, because you have to start somewhere. All right, so postulates and theorems, those are accepted, as well as definitions, all of our reasons there. Segment addition we kind of have touched on. But remember that with reflexive symmetric transitive, we saw the equals. Well, we can also use them as for segments. They can be congruent and use that property as well. All right, so let's take a look at this first one again. The reason is always given for our first one. If it's given up here, pretty much you start with the given. All right, so now we're going to see this word midpoint. They're telling us that it's the midpoint of AC, and then they're telling us that this side and this side are congruent. Well, what does it mean to be the midpoint? It means dividing it in half. So this is congruent to this. So if they give you the word, you're probably going to define it next, as that's exactly what they did right there. So definition of midpoint. Next, we're going to use definition of congruence. So what does it mean to be congruent? It means things are equal. And if we're talking about adding and doing things like this with solving, we have to change it from congruence to equals. So we're going to say that AB is equal to BC because congruent means equal. Definition of congruence means if it's congruent, it's equal. Segment addition postulate, left plus right equals whole. So this time they're talking about BC, this is the left, CD, this is the right, what's the whole? That's the question here. So it would have to be BD. And then what's changing from this step 4 to this step 5? It looks like this is the only thing that's changing. BC is changing to AB. Well, we know they're equal. So what is it called when I replace something with something equivalent? Substitution. Property of equality, or even just substitution is fine. All right, great job. First one's done. So let's take a look at this next one. We've got our picture over here to the right, and it does help as you go to mark your picture if you have kind of multiple pieces with it. But our first reason would be given. BC equal to DE because it's given to us. So we have to start somewhere. Now it's saying segment addition. Well, I only have this segment that has multiple parts to it. This is just a single segment there. So left plus right equals the whole. So left is AB plus right is BC, and it's going to equal AC, the whole. What's changing from this step 2 to this step 3? BC is changing into a DE because they're equal. So substitution. Okay, if you want to try this one, maybe see if you can fill some of those pieces in. Sometimes there are 2 givens, and sometimes a given is to start, and sometimes a given is given at a different point in the proof to lead you to kind of some other things. Sometimes all the givens are given at the beginning, but a lot of times if it's split up, I give you where it should go kind of. So this part is up here and it's given. And then our other given right here, we're going to put A, B, congruent to EF. Right there. So take your midpoint and define it. Definition of midpoint. What does it mean if B is in the middle? What does it mean for this segment and this segment? They would be congruent. So you should have AB congruent to BC, definition of midpoint. Always lead yourself from that first step to that second step. So then we're trying to get to this last statement here. We always put what we want to prove last. So BC congruent to EF, we know has to go here. It's going to go last. So it's not ever prove or proven. It's how did you get from step 3, sometimes 2 or 3, or a combination of 2 steps to get to that last one? Well, it looks like they took this one and put them together. So if they're both congruent to AB, they're congruent to each other by either transitive or substitution. I would accept either answer on that one. Of property of congruence, because we're using our congruence symbols here. So POC, property of congruence. Right, let's take a look at this proof here. Let's fill in our start and our end. So what's given goes here. And that is given. All right, so we're thinking that AB is equal to CD. Well, up here it was congruent, so if it's congruent, then it's equal by definition of congruent segments. And then substitution, so we're going to be plugging in. Well, let's see first, what are we trying to get to? So down here, it should be 2AB equals EF. Well, we're close. We just need to get that CD right here to be an AB, and then we'll have 2 of them. So I think that's what's going to happen right here, substitution. We're going to be replacing the CD with an AB for our step 3. So AB plus AB is equal to EF by our substitution. Now we have 2 of them, and that is not adding, that is just simplifying, because we're not doing it to both sides. Simplify or combine like terms. All right, if you want to try number 5 on your own, go for it. Kind of gives you a little piece of most things, but if you need to follow along, you can do that as well. So first is our given, and then we have definition. So this is what's given here, and then we're trying to prove this, so that's why it's down here at the bottom. Definition of congruence means it's equal, so AB is equal to CD. So if something equals itself, remember that's that reflexive property of POE, property of equality, because we have an equal sign. And then we have AB and BC is equal to AC. So that's left, right, and whole. That's our segment addition property, or segment addition postulate. And then, what do you think we're going to do next? Well, if we know that AB and CD, kind of look to see what's going to come in the future here. So we have CD plus BC equals BD. So it looks like we're probably going to replace the AB with a CD, because that's going to come. So I'm going to go ahead and instead of the AB, I'm going to put a CD plus, and then this stays the same. And that's substitution, property of equality. And then we're going to be replacing AC with BD. But we don't have anything to tell us that AC equals BD up here, so we can't just replace that. So let's go to our picture. Whenever you're kind of like, well, wait, what's happening next? Let's go to our picture. CD and BC is equal to BD. Hey, left, right, whole. We have that again. That's segment addition. So you can use it more than once. That's where they're getting it, is the picture, segment addition. So now, hey, these equal the same thing. So they are equal to each other, because basically you could plug this and replace it right here. So that would be substitution. And then equal to congruence, or congruence to equal, is definition of congruent segments.